All right, in this video, we're starting the next activity, activity 6. It's about proofs about line segments and angles. And lesson 6-1 is about justifying statements. Our learning goals are to use definitions, properties, and theorems to justify a statement. And we'll do this in the two-column format that we had discussed earlier this year. A proof is an argument or justification or reason that something is true. A proof is an answer to the question why when the person asking wants an argument that is indisputable. There are three basic requirements for constructing a good proof: awareness and knowledge of the definitions of the terms related to what you're trying to prove, knowledge and understanding of postulates and previous proven theorems relating to what you're trying to prove, and knowledge of the basic rules of logic. To write a proof, you must be able to justify statements. The statements in example A are based on the diagram to the right. So we'll be looking at this picture for example A, in which the lines AC, EG, and DF all intersect at point B. Each of the statements is justified using a property, postulate, or definition. Recall that earlier this year we have worked with some algebra proofs where essentially we're solving equations and then writing a reason for each step. These are geometry proofs about shapes. So example A, name the property, postulate, or definition that justifies each statement. So imagine that this column here was blank and we were coming up with these reasons. So to start, a statement might be, if angle ABE, right here, is a right angle, then its measure is 90 degrees. How do we know that? That is the definition of a right angle. Next statement, if angle 2 is congruent to angle 1, so if this is congruent to this, and angle 1 is congruent to angle 5, so here is congruent to here, then that means that angle 2 is congruent to angle 5. That's the transitive property of equality from algebra. Next one, given B is the midpoint of AC. Prove that segment AB is congruent to segment BC. So here in the drawing, if B is the midpoint from A to C, how do we prove that that piece is congruent to that piece? Like, what's the reason for that? That is the definition of midpoint. Next one, the measure of angle 2 plus the measure of angle ABE, so I see angle 2, and then ABE was this one, is equal to the measure of angle DBE. So D to B to E. What was the reason? We had studied this a couple lessons ago where two angles sitting side by side can create a larger angle. That's the angle addition postulate. Next one, if angle 1 is supplementary to angle FBG, so here's angle 1 and angle FBG, so this one right here, then how do we know that the measure of angle 1 plus the measure of angle FBG is 180? Well, because that's the definition of what the word supplementary meant. So in example A, we have 5 different questions where all we were asked to do is to give the justification for these if-then sentences. So it was a chance to practice some of the definitions and theorems from previous lessons. Now let's move to this try this problem. Using the diagram from the previous page that's shown again here, name the property, postulate, or definition that justifies each statement. So question A, EB plus BG equals EG. Here's EB, here's BG. Why do those two add up to that one? What was that called? That was the segment addition postulate. Question B, if angle 5 is congruent to angle 6, then ray BF bisects angle EBC. So if this is congruent to this, why does that ray bisect this angle? What was the thing we had studied that said that it did? That was the definition of angle bisector. Question C. If the measure of angle 1 plus the measure of angle 6 is 90 degrees, then angle 1 is complementary to angle 6. What's the reason why we would conclude that they're complementary if they add up to 90? What was that called? That was the definition of complementary angles. Don't mind if I abbreviate complementary angles, do you? Next, question D. If the measure of angle 1 plus the measure of angle 5 is equal to the measure of angle 6 plus the measure of angle 5, then the measure of angle 1 equals the measure of angle 6. Why can we make this conclusion? Well, to get this statement, what must have happened is we took the previous equation and subtracted the measure of angle 5 from both sides, subtracting the same things from both sides of an equation. What is the thing that allows us to do that? And that was called the subtraction property of equality. And finally, question E. Given that line AC is perpendicular to line EG, so given that this line is perpendicular to this line, how can we show that angle ABG, right here, how can we show that this is a right angle? Well, because that's what perpendicular means. That is the definition of perpendicular lines. So in this problem, we had 5 different questions, and each time we were practicing giving a justification for why the statements were made. Here are some check your understanding questions. So in this lesson, we practiced giving a definition, property, or theorem as the justification for a statement. We haven't yet made 2-column proofs yet, where we work step by step by step to come up with some kind of final statement. The ones that we did in this lesson were separate questions each time.